Hello everybody, welcome to day 2, Tools of Geometry. Okay, we're going to be discussing the distance formula. That is why I brought up Pythagorean's theorem the other day, only because it kind of helps introduce where this formula came from. Okay, so first we're going to talk about distance formula on a number line. Alright, nothing too exciting here, okay, but what the distance formula allows you to do is we're not a number line, we're just left to right. You don't have to worry about going up or down. Okay, so let me put a couple points on here. So let me say -4 and 8. Okay? Now, we could count. We could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The distance is 12. Okay? Or, what we can do, okay, this is just on a number line, x2 minus x1 equals the distance. Okay, so in this case I'll say x2 is -4 minus x1, which is 8. Okay, if you don't remember what those bars stand for, this is absolute value. So what that means is we're going to get a -12 here, but when you take the absolute value, you just get 12. Okay, so distance formula on a number line isn't all that exciting. So we'll go -10 and we'll go, how about -1? Okay, so we'll go x2 minus x1, which is -10 minus, don't forget, always use parentheses, -1. Okay, so we get -10 plus 1, which is -9. Take the absolute value of -9, and you just get 9. And if you counted, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So distance formula on a number line isn't all that crazy. The distance between 2 points is the length of the segment with 2 points, or with those 2 points as its endpoints. Let's shorten that up there. That's supposed to be endpoint there. Okay? So the length of the segment with those 2 points is as its endpoints. Okay? So a line segment. Right? This is a line segment right here. This is a line segment right here. And we just found the length of both of those line segments. So finding the formula for finding the distance on a number line, okay, looks like this. So distance is equal to x2 minus x1, or vice versa. You could go x1 minus x2, okay? What's nice about this formula is that it doesn't matter which point you put first as long as you stay consistent. And I'll show you what that means as I go on further. Okay, so I'm going to skip these 2 parts, finding distance examples, because I think you guys are pretty comfortable with that. So let's get right down to the nitty-gritty. All right, what is Pythagorean's theorem? So we discussed it the other day. Pythagorean's theorem is used only for right triangles and its formula is a squared plus b squared equals c squared, and it's used to find the length of sides of a right triangle only. Okay, so let's look at this graph over here. All right, I'm going to create a right triangle. Okay, so using Pythagorean's, I'm going to find this distance right here. Okay, so I'm going to count up. So I'm going to go 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5. So our length is 5 and 6. So remember, you can always screw up your A's and B's. Okay, the A's and B's, if you mess those up, it's okay because addition is commutative. But you always got to remember your C is always opposite the right angle. Okay, so I'm going to go 5 squared plus 6 squared equals C squared. This is going to be 25. This is going to be 36. C squared. This is going to be 61. Is equal to C squared. Take the square root, and the square root of 61 is equal to the distance of that line right there. Okay, so that's using Pythagorean's theorem. Okay, the distance formula, okay, takes those things into account and actually is derived from Pythagorean's theorem. Okay, so let me go down here and let me scroll to the distance formula. Okay, so the distance between 2 points is given by this formula here. So x2 minus x1 squared plus y2 minus y1 squared. Okay, and so the distance formula is derived from Pythagorean's theorem. Okay, so if you look right here to the left, right, you can see that this length here of C, just like we found up here, is actually equal to the square root of A plus B, right? Okay? And so what's happening here is this distance formula takes into account in finding this distance right here. So let me mark that in blue. Okay? So it finds this distance by going y2 minus y1 on the y-axis. And then it finds this distance by going x2 minus x1 on the x-axis, squares both of those, adds them together, and you take the square root, and you're left with the length of this side right here. Okay, so it's pretty cool that they use Pythagorean's theorem. Again, this 2,000-year-old formula is used in order to find the distance between 2 points on the coordinate graph. Okay, so in the coordinate plane. So in the coordinate plane, we use the distance formula to find the distance between any 2 points. The distance formula can be derived from Pythagoreans, and here is what the distance formula is. Okay, and I just always put it like this: D is equal to that. All right. Be prepared to simplify your radicals. Some answers may remain as irrational numbers. Okay, so that ties into what we were doing in that last section there when we were simplifying the radicals. In this particular unit, not all these distances are going to come out nice. Okay. Now, luckily for us, when we got back up here, okay, 61 is a prime number. Okay, and so we can't simplify that any further. So we were done there. Okay, but be prepared that not all of these answers are going to be nice. Okay, so as you can see, all right, in this first section, okay, it says find the distance between points 2, 3, and 1, 1. We can sketch the right angle triangle PQR with PQ as the hypotenuse, okay, the hypotenuse leg, or your C value. All right, so it says find the distance between these 2 points. As you can see, they've already created the right angle for us, or the right triangle. Okay, and so in order to find this distance, okay, now again, it doesn't matter which point you choose, as long as you, as long as you make sure you stay consistent when you put them into your formula. So what I like to do, gosh, I keep drawing an X there, is I go, oh my Lord. There we go. Okay. So, now my computer's froze. There we go. So, what I like to do is I like to put x1, y1 over one particular point and x2, y2 over the other particular point. That lets me know that when I go to use this formula, okay, all I got to do is just look and make sure I put those numbers in the right place, okay? So what it does is it allows me to just make sure that I'm not making, it just helps me to make sure I'm not making too many mistakes, okay? And it doesn't matter which one you use. We can also make this one x2, y2, x1, y1, okay? It really doesn't matter, right? As long as you stay consistent and put those points in the right place, okay? So our distance formula, again, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And so I just fill in the blanks. So my x2 in this case is 2 minus x1 is 1 squared plus y2, which is 3, minus y1, which is 1 squared. All right. Shorten this up here. So I'm running out of room. Whoops. Sorry, I'll fix that. Okay. And so finally, 2 minus 1 is just 1 squared, plus 3 minus 1 is 2, so 2 squared is equal to the square root of 1 plus 4. And you get a square root of 5. Okay, so this distance is about, all right, so it's square root of 5, so what they're saying is it's about 2.23 units long. Okay, which sometimes it doesn't hurt to just check to make sure that makes sense. So I would say that looks about right. Okay, this was 1 unit. This is 2 units. Right, and so if you go back to a squared plus b squared equals c squared, right, we got 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared, so we get 5. Take the square root. And again, you're still getting square root of 5 for your answer. Okay, so it's kind of neat. The Pythagoreans and the distance formula does both of these things for you. Okay, so the solution, square root of 5. Okay? And because we're on the coordinate plane, we don't have to put any units there. All right, last two, and then we'll call it a day. So find the distance between these 2 points. So first, let's find what these 2 points are. So this point, oh, let me get a different color here. This point right here, okay, is, let's see, so back 5, so negative 5, 1, 2, 3, up 5. Okay, cool. And this one is 1, comma, negative 2. Okay, so find the distance between these 2 points. Okay, so I'm going to go, let me put these points up here and label them. So I'm going to go x1, y1. Go x2, y2. I can scroll in here, okay. Our distance formula, square root, so it's going to go x2 minus x1 squared plus y2 minus y1 squared. Fill in the blanks. So I'm going to go 1. Zoom in here a little more. So that's, oh, lost my point. So I'm going to go 1, x2 minus x1, so put that in parentheses, square, plus y2, negative 2, minus y1, which is 5, squared. All right, so this becomes 1 plus 5, so it's going to be 6 squared. Negative 2 minus 5 will be negative 7 squared. So we get 36 plus 49. 36 plus 49 is equal to square root of 85. Okay? Now, it's not simplified yet. I'm just going to verify using Pythagoreans that we got the same thing. Okay? So I'm going to count my units here. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So a squared plus b squared equals c squared. And again, you can see 36 plus 49 equals c squared. We end up getting 85 is equal to c squared. Take the square root. C is equal to the square root of 85. Okay. Now, let's simplify this guy. All right, so let's go up to the top here. So square root of 85. Do the hockey stick method. So 5, I don't know, 85 divided by 5, what's that equal to? 17. Oh, can't go any farther, can we? Nothing but prime numbers, right? Then we are done. Okay, so that's what you're looking for. When I got to 5 times 17, I know both of those are prime, so therefore I cannot use prime factorization. I'm done. Okay, let's look at this one over to the right here. Okay, so let me clear out some of this stuff. Move it over here. Down here, I'll move it down there. All right, we'll just skip this problem altogether down below. Okay, so how about right here? So let's find these points here. So this point is -4, comma 2, and this point is -4, comma -4. Okay. All right, I'm going to go x1, y1, x2, y2. Distance formula. So we'll go x2 minus x1 plus y2 minus y1 squared. If you look over here on the left, okay, we're going to get a -4 plus 4 squared, so those are going to cancel. Okay, we're going to have plus, this is going to be -6 squared. So we get 36. Square root of 36 is just 6. Okay, so let's count to be sure. How many units? 1, 2, 3, 4, 5, 6. So this line segment is only 6 units. Okay, one more down below, and we'll call it a day. So here, we're not given the graph. That's all right. I can still find this distance. We don't need it. So I go distance is equal to x2 minus x1 plus y2 minus y1. So our x2 is -2 minus x1, that's -6 squared, plus y2 is -10 minus y1 squared. Okay. Make sure when you got a negative on there, you got to put those in parentheses. Okay. So now, we got -2 plus 6 squared. And over here, we got -10 plus 10 squared. So that's going to cancel. So now I'm left with -2 plus 6, which is just 4 squared, which is just 16, which is 4. And if you think about it, if we drew this graph, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let me see, 1, 2, 3, 4, 5, 6. So our points were -6, 10. And then -2, 10. And so that line segment is only 1, 2, 3, 4 units long. Okay? All right, so that's the distance formula. Give the homeworks a shot here. I'm going to say for your homeworks, do the odd problems. So you have the odd problems for homework.